In this video, we're going to be learning about simple machines. The three types of simple machines that we'll be looking at are levers, wheel and axles, and pulleys. We will also be looking at calculating the ideal mechanical advantage of these simple machines. The first simple machine that we'll be looking at are levers. There are three types of levers. There's a first class, second class, and third class levers. A seesaw is a great example of a first class lever. This is where you have a fulcrum in the middle and two force or loads at the end of the lever. A wheelbarrow is a great example of a second class lever. The wheel in this case acts as the fulcrum. The weight or the load is in the middle in the bucket, and the force that's being applied is the child lifting the wheelbarrow. A fishing rod is a great example of a third class lever. The end of the rod that is attached to the man's waist acts as the fulcrum. The reel and his hands are the effort force that's pulling on the load that's attached to the end of the rod. To calculate the ideal mechanical advantage of any type of these levers, you need to know the distances. You need to know the distance of the effort from the fulcrum and the resistance or the load to the fulcrum. A wheel and axle is the next simple machine that we'll be looking at. The wheel has a diameter that you'll need to know, and the axle also has a diameter that you will need to know to calculate the ideal mechanical advantage. To calculate the ideal mechanical advantage of a wheel and axle, you need to know the distance from the center of the axle to the effort and the center of the axle to the resistance force. In this case, the axle is the effort force, and the end of the wheel is the resistance force that would ride against the road. A pulley is the last simple machine that we will learn today. However, this might cause the most mechanical advantage out of all of the simple machines. You can combine many pulleys to increase your mechanical advantage. To calculate your ideal mechanical advantage for the pulley, you need to realize if it is a fixed pulley or a movable pulley. A fixed pulley will always have a mechanical advantage of 1 to 1. A movable pulley, in this case, will have a mechanical advantage of 2 to 1. If you multiply more pulleys together, you will just continue to add your mechanical advantages. This was Mr. Smith with Principles of Engineering. Have a great day.